In this tutorial, I'm going to show you a common motion technique. It can be used for particle systems, or moving a character in a game, or moving enemies in a game, or just doing basic effects. So I'll create a new folder called Motion, and I'll put an index.html in there. I'll start with a regular HTML5 document, and I'll give this document the title of Motion. I'll create my window on load function. And in previous tutorials, I've created the canvas tag down here. Just for variation, I'm going to create it on the fly with JavaScript. So I say create element canvas. I'll immediately get the context. And now I'll set the canvas size. I'll add it to the body. And I'll fill it with black. Okay. Now, this extra space that you see here is just the default margin and padding on the body tag. And if for some reason you wanted to get rid of that, you could just say body HTML margin 0px padding 0px, like that. So first I'm going to show you the basic principle behind this motion technique. It uses 4 variables. I'll start with the first 2. Position X, I'm going to set equal to, let's set it to half the canvas height, or width rather. Position Y. And then I'll start an interval. Every 30 milliseconds, it's going to repeat. And I'll say position X plus equals 1, position Y plus equals 1. I'll say C fill style equals white, fill rect based on position X and position Y. Let's make it kind of big so we can see it. And there it goes. It's just starting at the center of the screen, shooting a diagonal off the bottom of the screen. Now, it's a little hard to tell what's going on because I'm not erasing the canvas, so I'll copy this bit of code so that I'm continuously erasing the canvas, and this box sort of animates to the right and down. Now, it's moving on both the X and Y axes, so if I don't move on the Y axis, it's just going to go directly right. If I move negative on the x-axis, it's going to go left. Similarly, if I don't move on the x-axis and I just move positive 1 on the y-axis, it's going to go down. Negative 1 on the y-axis is going to go up. So we have all directions here. The combination of directions is what gives us diagonals. And that weird squeaky sound was my chair rubbing up against my desk. Okay. Gotta stop doing that. Now, these numbers, 1 and 1, if I change them to say 10 and 10, it moves faster. And I can change it to say 5, and it's going to move a little slower. I can do different direction. In class, when I'm teaching this lesson, I always ask the students, what is that 5? What's it controlling? And they say, speed. And I say, yeah. Technically, it's velocity. So we say Vx for velocity x equals 5. And we say Vy for velocity y equals 5. Now, this does the exact same thing. What's so good about putting it into a variable? Well, what's good about putting it into a variable is that we can alter that variable over time. For instance, if I say Vx times equals 0.9, I don't know if you saw that, but I'll show it again. There's a little curve happening there. And if I do this on both axes, something interesting happens. It slows down and stops. This happens because I'm multiplying the velocity x and velocity y, which are both 5, by 0.9 every time. So they're reducing 10% every 30 milliseconds. And eventually it gets so small that it stops moving altogether. I could do it by a little bit of a higher number. And that's actually unnoticeable. Let's try this. And this is sort of like a friction effect. So something else that we can do by altering the velocity over time is to, let's go negative on the y velocity, so it's shooting up. And then in our code, we'll say, in our loop rather, we'll say Vy plus equals 1. Now, what's happening here is velocity y is negative 10, and then we add 1 to it, so it becomes negative 9. And then we do that again, it becomes negative 8, 7, 6, 5, 4, 3, 2, 1. Then it becomes 0, then it becomes positive 1 and reverses direction. So we get an arc happening. And this is sort of like gravity, so we could put that into a variable called gravity. Now I'm going to move my starting x position over to like 20. And I'll say if position y is greater than, how big is my canvas again? 400. Let's say greater than 300. Position y equals 300. So it stops at 300, stops moving on the y at 300 pixels. We could then reverse the velocity by multiplying it by negative 1. And we get a bounce effect. Now if we multiply by a negative decimal value, like 0.5, it's going to lose some of its velocity every time it hits the ground. Now I'll also do the same thing for the x velocity. And you'll notice it's sort of bouncing and bouncing and bouncing and bouncing. And if we just move our gravity code, that resolves that issue. Something interesting here is that you can accidentally put a negative sign on your velocity x alteration, and this particle sort of jumps back and forth. I don't know if you saw that. I'll test it again. That's a mistake I made commonly, but in the past I've actually used it for motion of enemies in games. So this is the basic concept. You can do a lot of different kinds of effects if you understand how to use these 4 variables together. You could create fireworks and all kinds of particle systems. As I said before, you could create a player in a game. It's really powerful stuff. Now, if you want to make a lot of them, this method of having 4 variables just hanging out here really doesn't cut it. You'd have to duplicate this whole part again and again and again, and it becomes really tedious. So what we can do is make a custom object called particle, and I'll give it properties. This.x, for the previous variable was called posex, so I'll say this.x, and I'll put it at canvas width divided by 2. This.y equals canvas height divided by 2. This.vx We'll just make it random. Then on the custom objects prototype, we'll add the logic for how to deal with these variables. So I'll say particle prototype draw this dot x plus equals this dot vx, this dot y plus equals this dot vy. For simplicity, we're not doing anything with gravity yet, or any kinds of effects. We're just going to shoot them all off in random directions. Let's see, fill style equals white. Now, we can test this one particle by making a new particle, and we'll say set interval p dot draw, and it worked nicely. Now we want to clear the canvas again and again. Now, having a lot of these is really easy with an array, but if you put it into an array, it's a little tricky to delete the particles when they leave the screen. Now, it's not impossible, but it's a little bit tricky. I like to use an object for this, so I'll create an object called particles, and then I create a variable called particle index and set it equal to 0. Now, every time I create a new particle, particle index gets incremented, and particle index gets set equal to the newly created particle. Now, I'll also give this an ID of whatever particle index is. So this ID can tell me where inside the particles object this current particle is. So if I wanted to delete this particle after a certain amount of time, all I have to do is delete from particles this.id. So there are a lot of ways you can kill off a particle. One way is just saying when it leaves the screen. Another way is by giving it a life. Another way is by just maybe altering its alpha, fading it out, and then when it's 0 you delete it, or scaling it up. When its scale is 200% you delete it. So altering some kind of property and then deleting it when the property meets some sort of requirement. I'm going to give it a life because that's kind of a fun thing to do. I'll say this dot life equals 0. This dot max life equals, say, 100. So it'll iterate 100 times and then die. So I'll say this dot life plus plus if this dot max life, if this dot life is greater than or equal to max life, we can just say is equal to particles this dot ID, we delete it. Now we need to set up our code to actually run this way. We'll loop to something called particle num, which I'll set in a moment. And let's go ahead and set that. Particle num equals 10. And I'll say particles, or no, I'll say new particle, like that. Now in here, for I in particles I.draw. There we go. And you can see the life is working. Let's set the max life to 10 and see what happens. So they just die. Let's set the max life to some random value, math.random times 100 plus 100. That's a little long, so let's do like a random 30 plus 10. Oh, now it says equal to. That's why I did greater than or equal to. Pretty cool. Let's increase the number of particles. Let's add in some gravity. And gravity is way too strong. Let's set it to something low. Now it might be nice to have an emitter of some kind. So the emitter would be continuously creating particles, which we can do just right in here. Instead of saying particle num, because that's way too high, we'll do something like 10. Or we could just use particle num, and that's how many get added every 30 milliseconds. Let's put some alpha on these particles. Now we could really do some strange things here. I'll do one thing and then I'll wrap up. Something strange that I could do would be to say if math random is less than 0.1, this.vx equals math.random times 10 minus 5. So what that did is every so often we re-randomize the velocity x, and we can do the same thing for the velocity y. Now let's give them a little bit of a longer life. Let's give the emitter less particles. Let's erase with a transparent color, like transparent black. It starts to get kind of interesting. Something that students ask me around this point is, well, you know, how do you add color, or how do you do a randomized color? And you can do this in a number of ways. One of the easiest is to just use string manipulation here, where basically when we initialize the particle, we'll say this dot color equals RGB plus parse int math.random times 255, and we like to put the radix argument on parse int if we're doing best practices. So I've randomized my red channel. And actually, let's just do that. So now they have random value between 0 and 255 in their red channel. Now we could do the same thing for the green channel and the blue channel, but we could also use HSL here, and you need percentage signs for your last two arguments, and then we'll put this at like 50%, 50%. So that's a little bit easier. HSL's first argument is the hue. So we give it a random hue between 0 and actually 360. Then we've got saturation, which is 0 to 100%, which I'll just put at 100%. And then we have lightness. We can darken up all the particles, or let's just put them at 100%. Oh, that's going to be pure white, of course. That's why I did 50 in the beginning. So that's an easy way to get a random color in there. And if you wanted to randomize the alpha, just add alpha, you could do HSLA and then say 0.1, 0.2. Now this particle system actually just gave me an idea, something that I forget how to do. There's a way to do an add effect so that when these things are over top of each other, the pixel colors will sort of add together. Now I don't remember the syntax for that, but I remember writing it before, so I'm going to look it up. These are some HTML5 graphic experiments that I do. I'm going to find the one where I mess with that. Just bear with me. Here it is. Yeah, you can see why it's tough to remember. So we'll do it global composite operation. Needs to be the normal setting when we draw the black background. And then before we draw the particles, we set it to lighter. And as you can see, when the particles are over top one another, they have this sort of brightness, look almost overexposed. Now, to wrap up, I'll add way more particles. And that's the end of the tutorial.